Okay, shout out to Leo for highlighting this question, which is quite a tricky one. So I'll go through the whole of question 9 and hopefully this will help you. This is a question about pressure in a gas. So this was in particle model. So a teacher demonstrated the relationship between pressure in a gas and volume of a gas. Figure 12 shows the equipment used. We've got a pressure gauge, we've got a syringe, we've got a plunger, and we've got some weights here which will pull the plunger out as you add weight to it. And the method used was to record the initial volume of gas in the syringe and the pressure reading before any weights are attached. So our initial reading of the weights is 0 newtons. We then attached 2 Newton weights to the syringe, recorded the volume of the gas and the reading on the pressure gauge, and we repeated stages 2 and 3 until a weight of 12 newtons is attached to the syringe. So the first question is fairly straightforward. What was the range of force used? Well, it was 0 to 12, as I said as I was reading the question. And then give one control variable of the investigation. Well, the control variables here are the mass of air inside here. The volume's going to change because we're going to pull this plunger out. The volume's going to increase. But the mass of air in there is going to stay the same. Also, the temperature in there has got to stay the same as well if we're only changing one variable. So the mass of the air in the syringe or the temperature of the air, of the gas, would be two of our constants. Okay, this is the one that was causing a little bit of an issue. Now, on the equation sheet, you've got this equation that says PV equals a constant. Now, what that means is the pressure multiplied by the volume at the start must be equal to the pressure multiplied by the volume at the end. So I've called these P1 and V1 and P2 and V2. So if we read the question, it says when the volume of gas in the syringe was 45 centimetres cubed, so I've called that V1, the pressure gauge showed a value of 60 kilopascals, so 60,000 pascals. So I've called that P1. Sorry, P1 there. Okay, so we've got V1 and P1. So if we multiply 45 and 60, we will get our constant. But to save time, I've just said P1 V1, so that constant, equals P2 times V2. Now, it says calculate the pressure in the gas when the volume in the syringe was 40 centimetres cubed. So in other words, calculate P2, and here's V2. So V2 is there, which is 40. P2 is our unknown. So all I've done is put in the numbers. I put in P1, which was 60 kilopascals. I've not converted because they're both in kilopascals, or my answer can be in kilopascals. I've looked ahead and seen, do you know what? They want to keep it in kilopascals, so I might as well. So I've not converted that to pascals. I've not turned it into 60,000, for example. So I've got 60 multiplied by 45, those numbers I got from the question for P1, V1. And then I equated it, or put it equal to P2, which is my unknown, multiplied by my V2, which is known. And then it's a simple case of doing the maths, and you get 67.5. So that looks complicated, but once you've remembered that this on the equation sheet means that, then you're fine. Or like the mark scheme says over here, you can just put constant equals 60 times 45, or constant is 2,700, and then 2,700, which is what those numbers are, equals P times 40. So if you look over on the right-hand side, you'll see the mark scheme there. Then we get when 9.4, when the volume of gas in the syringe increased, the pressure on the inside walls of the syringe decreased. Now remember, when we're doing, it says explain why. When we're doing questions like this, you've got to talk about collisions between the particles and the walls. That's important. So if we're increasing the volume, the time between the collisions and between the particles and the wall will actually be increased. There's going to be more time because they've got to travel further, basically. So they're going to be the same temperature, so they're going to be travelling at the same speed. Remember, the average kinetic energy is going to be equal to the temperature. So they're going to be going at the same speed, but if they've got further to travel to hit the walls, there's going to be more time between collisions. That's then going to lower the average force of the walls. Force of walls on doesn't make any sense. Let me just so lower average force of particles on walls of syringe is what I should have written. Particles on walls of syringe, great. And then we've got the last bit. If you've got lower average force, then you've got lower pressure for any given area. because pressure is force divided by area. And again, if you look over on the right-hand side, you'll see those statements made there. Right, that's the end of question 9. I'm going to go through question 10, but I'll do that on another video.